Yellowstone National Park, known for its hot springs and geysers, is one of the largest volcanoes in the world. Its gigantic caldera sits on a huge rhyolitic magma chamber, one of the most volatile and explosive types of lava. Throughout its history, Yellowstone supervolcano has had 3 catastrophic eruptions, according to the USGS. These occurred at 2.1, 1.3, and 0.64 million years ago. These combined eruptions have created a caldera 45 by 85 kilometers. The largest eruption occurred 2.1 million years ago. This blast had a volume of over 2,500 cubic kilometers. The eruption of Mount Pinatubo in 1991 had a blast volume of just over 10 cubic kilometers. The Mount Pinatubo eruption blasted 20 million tons of sulfur dioxide into the atmosphere, dropping the global temperature by 0.5 degrees Celsius from 1991 to 1993. Although this may sound like a negligible amount, remember that even the smallest change in global average temperature may drastically alter the climate of the Earth. 1991 to 1993 produced some of the coolest, wettest summers in recent history, causing major flooding in the Mississippi River. If the global temperature were to drop by several degrees Celsius, this could alter the Earth's climate much more dramatically than the eruption of Mount Pinatubo. This drop in climate could cause crops to die off worldwide, resulting in widespread famine. It is estimated that a supervolcano could drop the global temperature by 5 degrees Celsius. This would almost certainly be a global catastrophe. Per graphic on the USGS site, ash from the largest Yellowstone eruption was spread incredibly far. The northernmost ash reached Canada, while the southernmost ash went through Texas and into Mexico. From east to west, much of the west and midwest regions were covered in ash. This is problematic as much of the food consumed in the United States is grown in the Midwest. According to the USGS, crop survival is impossible past an accumulation of 10 to 15 centimeters of ash, and even reduced amounts of ash can have a negative effect on crops. Volcanic ash is also incredibly abrasive. It can damage almost any type of machinery it enters. This is why airlines will divert routes around potential eruptions and will declare vast no-fly zones around volcanic activity. Ash combined with water can also become extremely heavy. A combination of rain and volcanic ash destroyed many homes during the Pinatubo eruption. Although the initial blast would only affect much of the region in the United States, other effects such as sulfur dioxide in the atmosphere and volcanic ash would create disastrous worldwide effects. Intense global cooling caused by sulfur dioxide could cause drastic changes in weather, wiping out crops worldwide and causing widespread famine. Ash throughout the United States would also disrupt much of the Midwest's food production, causing famines and scarcities locally. Additionally, volcanic ash would have disastrous effects on the infrastructure.
All right. There's no doubt that the effects of another Yellowstone super eruption would be devastating, but the scale of devastation is often a topic for debate. Things like lava flows, wind-flung ash, as well as sudden climate shifts are all possible when discussing another eruption event. However, most of these effects are greatly exaggerated. It's become somewhat of a hot topic to talk about the effects of another Yellowstone eruption and how it could possibly end the world as we know it. Depictions from lava flowing for hundreds of miles and destroying anything in its path to volcanic ash being sent high enough into the atmosphere that it could send us into a new modern-day ice age are often very misleading and have very little scientific merit to them. According to many studies, these results would be on a much more regional level, affecting much of the United States as well as parts of Canada. The greatest threat is volcanic ash being flung into the air. While this would have devastating effects on Midwest agriculture, as well as streams and creeks in the Midwest and surrounding areas to be clogged with this gray muck caused by the ash, some areas such as Southern California, Florida, and Southern Texas would only receive the dusting of ash. Areas in close proximity within 100 miles may receive upwards of 3 feet, which could be potentially harmful and very disruptive. But much farther out in cities such as Lincoln, Nebraska, Salt Lake City, Utah, or Fargo, North Dakota, estimations are they would only receive about 1.5 feet of ash, And as we move farther out from the blast site, cities like San Francisco, California, Kansas City, Missouri, Minneapolis, Minnesota, they would receive about an inch, possibly less, of ash. And all these are according to a 2014 United States Geological Survey study. Number two, the lava flows would not be much of a threat. In the previous events, scientists were able to determine that the lava didn't travel much farther than the park boundaries. Again, these USGS studies have concluded that this type of eruption does not have a large amount of lava flow that comes to the surface and destroys things. Most of the disruption is the volcanic ash and volcanic strata that's spewed from the volcano. Many gases, including sulfur dioxide, would be emitted into the atmosphere that could affect the climate in many parts of the United States. Sulfur dioxide forms a sulfur aerosol that absorbs and reflects sunlight back into space. A result of this would be a lowering in temperatures for up to a decade, but these temperatures would only be felt for the most part around North America. Much of the other global climate would remain unchanged. And as a result of this, Midwest agriculture would be wiped out. Just a backstory that has kind of already been touched on. The previous eruptions occurred 2.1, 1.3, and 640,000 years ago. Most of Yellowstone National Park sits on 3 overlapping calderas. These calderas were formed when the previous eruptions occurred. The magma chamber for these calderas sits 3 to 6 miles beneath the park, and another eruption is not expected for another 250,000 to 500,000 years.
Okay, well, if you look at the history of eruptions, 2.1 to 1.3 million years ago, that's about 800,000 years, and then 1.3 to million to 640,000, that's about 7. So really, if you look at the progression between eruptions, we're getting close to being due for another major eruption, if that's the only thing you look at.
Yeah.
Also, the eruption of sulfur dioxide into the air, that would go and cover the entire Earth. And it's known that sulfur dioxide is kind of a reverse greenhouse gas. It's kind of the opposite of what carbon dioxide does in the atmosphere, by forming aerosol particles and reflecting sunlight back into space. And occurrences of this have been well known throughout history. According to Science magazine, back in the there's a time known as the Little Ice Age, which happens, I believe, in the 6th and 7th centuries, when increased volcanic activity created record low temperatures, and this resulted in poor crop output, famines. And interestingly enough, this Science magazine article suggests that the mass migrations caused by the famines as a result of the increased sulfur dioxide in the atmosphere allowed the plague to travel, which in result killed off many humans.
Okay. So when you said, when you were talking about the dispersion of ash, you said it would reach Mexico. While yes, it would travel into Canada and Mexico, as I said, many places it would almost be a dusting or trace amounts. They may see some, but again, according to this 2014 study, they said that much farther out of 500 to 600 miles away from the initial blast site, the effects wouldn't, I don't want to say minimal, but they would be negligible, and humans would be able to, or mankind would be able to somewhat survive and thrive and, I guess, get through it.
Well, I'm sure mankind would survive, but there would be devastating effects worldwide. I mean, if the United States was able to feel the effects of Mount Pinatubo's eruption with flooding in the bed of the Mississippi River, I'm sure that an eruption in North America could have the same effects on the other side of the globe. And this isn't necessarily due to volcanic ash. This is again due to the other gases that are being released into the atmosphere. The sulfur dioxide, which again acts as the reverse greenhouse gas, and this envelops the globe. Another instance of this happening was the Krakatoa eruption in the early 19th century, and there was again instances of global cooling that happened in the years following the eruption. And this is also on the image that I talked about that shows volumes of volcanic eruptions with the largest Yellowstone eruption being 2,500 cubic kilometers. Krakatoa was much smaller. So if you think about the effects being multiplied as much as the dispersion of gas and ash, then it looks like we could have a real catastrophe in another Yellowstone eruption.